note that there is unknown quantity x in the denominator, so we could not multiply minus 5x minus 6 because we don't know whether it's positive or negative. So we should move the 5 constants to the left-hand side. Okay, so the original problem is equivalent to 3x minus 4. Okay, just move 5 to the left and rewrite the whole expression using the common denominator, which is minus 5 minus 6, right? All right, next step, we should expand the numerator and try to simplify. So note here, minus 5 multiplied with minus 5x gives us plus 25x, right? And minus 5 minus 6 multiplying together gives us 30. So this is a numerator. Denominator, of course, is a common denominator minus 5x minus 6. And this expression is below 0. Right? And next step, we need to simplify the numerator, which gives us 28x plus 26 over minus 5x minus 6, right? And this should be below 0. And of course, we can divide both sides with a 2, right? So left-hand side divided by 2 is 14x plus 13. Because 2 is a positive number, so we don't change the direction of the inequality symbol. And 0 divided by 2 is, of course, still 0, right? Okay, so now we have a ratio that is below 0. This is equivalent to, if you have a number, the ratio of these two numbers is below 0. That means the sign in front of this number should be different, right? So it could be either the numerator is negative and denominator is positive, or we can have a positive numerator but a negative denominator, right? Pay attention that the signs in front of these two numbers should be different. One of them is, if one of them is negative, the other one should be positive. Whereas if one of them is positive, the other one should be negative, right? So the original problem is converted to two separate problems, which we can solve separately. Okay, so first expression is equivalent to x is less than minus 13 over 14, right? And second, x should be less than minus 6 over 5. Or we can also have x should be greater than minus 13 over 14. And at the same time, x should be larger than, sorry, there's a typo. This should be a negative sign. Or x should be larger than minus 6 over 5, right? Then we need to check if we can combine the two solutions. So which of the two numbers is larger? So minus 13 over 14 is 13 over 14 is less than 1, right? So this is a number that is greater than minus 1. And the second number is minus 6 over 5. 6 over 5 is about 1.2, right? So this number is minus 1.2. So which number is larger? Of course, the first one is larger, right? That means if you draw a number axis, minus 6 over 5 is here, and minus 13 over 14 is here, right? Okay, now we can check that we can combine the two solutions. Okay, first solution, x is smaller than two numbers. The final result is x should be smaller than the smaller number, right? As we have discussed, minus 6 over 5 is smaller. So the first solution is x should be smaller than minus 6 over 5. Or if you have x larger than two numbers, the final solution is x should be larger than the larger number, right? So the second solution is x can be larger than minus 13 over 14, right? So our final solution is here. This is our final solution. Okay, any questions? This is the whole reasoning process. Okay, have a look at this. Any questions, please let me know, okay? All right, if you have no questions, let's have a look at question number 2. Okay, the methods are similar. First of all, we need to move 4, constant 4 to the left-hand side, right? Original inequality is equivalent to minus 4 greater than 0, right? And rewrite expression on the left-hand side using the common denominator, which is 7x minus 5. Okay, and expand the numerator and try to simplify that. Minus 2x plus 1. Okay, minus 4 times 7x gives us minus 28x, right? And minus 4 times 5 gives us minus 20. Okay, just do this slowly, one step at a time. And common denominator, of course, 7x plus 5. And this expression should be greater than 0, right? Okay, next step, simplify the numerator, which gives us minus 30x. And plus 1 minus 20 is minus 19, right? Ah, sorry, there is a typo. This should be 7x minus 5. Sorry, my fault. Should be minus sign here. Okay, so this is not minus 20. This should be plus 20. Okay, plus 20 plus 1 gives us plus 21. And denominator is 7x minus 5, right? And this should be above 0. Okay, note that minus 30 and 21 has a common denominator, a common factor 3, right? So we can divide both sides with a 3. And try to simplify this a little further. Okay, because 3 is positive. So if we divide both sides using 3, we don't change the inequality symbol here. And 0 divided by 3 is still 0. Okay. Okay, now we have a ratio that is a positive number. That means both of the numerator and denominator should be positive, or both of them should be negative, right? So this is equivalent to either the numerator is positive and at the same time the denominator is also positive, right? Or the numerator is negative and at the same time the denominator is also negative. You understand? Okay, Dora, do you understand why this is equivalent to the original expression here? Okay, good. Okay, so now we can solve these two sub-questions separately, right? First gives us x is smaller than 7/10, right? And second gives us x is larger than 5/7. Or the second problem gives us x should be larger than 7/10, and at the same time, x should be smaller than 5/7. So now we need to consider which number is larger, their relative positions on the number axis. Okay, 7/10 is 0.7, right? And 5/7 is, okay, let's see, 5/7 is 0.714. So this is about 0.714, right? And now can you tell which number is larger? Of course, 5/7 is larger, right? If this is 5/7, 7/10 should be here, which is smaller than 5/7, right? Okay, so what is the final result? Final result is, okay, let's consider the first subproblem. Says x is smaller than 7/10 and larger than 5/7. So there is no solution for the first sub-question. And the second question says x should be smaller than 5/7 and greater than 10/7. So this should be the solution of the second question, right? So, or x is within 5/7 and 7/10. So the final solution is either x belongs to an empty set or x is within 7/10 and 5/7. So what is the final result? Final result is by considering both of the cases. So the final result is x should be larger than 7/10 and smaller than 5/7, right? This is our final solution. Okay. Any questions? Okay, I'll give you some time to have a look at this. Any questions, please let me know. All right, let's see the next one. Question 3. Okay, again, this method is similar to the previous one. The original problem is equivalent to, let's move the constant 7 to the left-hand side. And this expression is above 0. And rewrite the expression on the left-hand side using the common denominator, which is minus 7x plus 4. Minus 7x plus 4. And this is equivalent to expand the numerator. The minus 7 times minus 7x gives us 49x. And minus 7 times 4 gives us minus 28, right? Okay, common denominator is minus 7x plus 4. And this should be above 0. And next, let's try to simplify the numerator, which is 57x minus, so note here, minus 28 plus 9 is minus 19, right? I can see that some of you have done this incorrectly. So pay attention, do not confuse number here. Minus 28 plus 9 is, of course, minus 19, right? Over minus 7x plus 4. Greater than 0. Okay, and now we have a ratio of two numbers that is greater than 0. So what is the equivalent expression? This is equivalent to either the two numbers are positive or both of the two numbers are negative, right? Understand? So first of all, numerator is positive, and at the same time, denominator is also positive. So positive number divided by a positive number gives us a positive ratio. Or we can also have a negative numerator and a negative denominator. So negative numerator divided by a negative denominator also gives us a positive ratio, right? Okay, so next we solve these two sub-questions. First question gives us x is larger than 19 over 57. 19 over 57 is actually can be simplified with a 19, right? If you divide both the numerator and denominator with a 19, this is actually 1 over 3, right? And second expression gives us x should be smaller than 4 over 7. Okay, next, x should be smaller than 19 over 57. Of course, 19 over 57 is 1 over 3. Next, x is larger than 4 over 7, right? So we need to decide which number is larger. 1 over 3 is about 0.333. And 4 over 7 is about 0.5 something, right? So which one is larger? If we draw a number axis, of course, 4 over 7 is larger, right? If this is 4 over 7, 1 over 3 should be here, right? Okay, so what is the solution of the first sub-question? It says x should be larger than 1 over 3 and smaller than 4 over 7. So considering the relative positions of 1 over 3 and 4 over 7, the final solution of the first sub-question is x should be smaller than 4 over 7 and larger than 1 over 3, right? So how about the second sub-question? It says x should be smaller than 1/3 and should be larger than 4/7. So considering the relative positions of these two numbers, there is no solution for the second sub-question, right? Okay, so by considering both the first and second sub-questions, final solution should be x is either within 1/3 and 4/7, or x belongs to an empty set. So the final solution can be combined to x should be within 1/3 and 4/7. Okay, any questions? No? All right, let's see the next one. Question 4. Okay, again, we use similar method to all previous 3 questions. Original problem is equivalent to minus x plus 9 over minus 3x plus 2 subtracted by 9 is less than 0. And this is further equivalent to minus x plus 9 over minus 3x plus 2. We rewrite the expression using the common denominator. Okay, and this is equivalent to numerator is minus x plus 9. Minus 9 times minus 3x gives us 27x. And minus 9 times 2 gives us minus 18 over minus 3x plus 2. Should be less than 0, right? And this is equivalent to 27x minus x is 26x. And 9 subtracted by 18 is 9. Okay, divided by minus 3x plus 2, and this should be less than 0. Okay, and now we have a ratio that is less than 0, which is a negative number, right? That means the signs in front of the numerator and denominator should be different, right? If one of them is negative, the other one is positive. If one of them is positive, the other one should be negative, right? So this is equivalent to, we can either have a negative numerator and a positive denominator. Okay, negative divided by positive gives us a negative ratio. Or we can also have a positive numerator and at the same time a negative denominator. So a positive number divided by a negative number gives us a negative ratio, right? Okay, so the solution of the first sub problem is x should be less than 9 over 26, and x should be less than 2 over 3, right? And the solution of the second problem is x should be larger than 9 over 26, and x should be larger than 2 over 3. Now we need to consider the relative positions of these two numbers here. Which one is larger? Okay, so 9 over 26 is about 0.346 something, right? And 2 over 3 is around 0.667, right? So which one is larger? Of course, 2/3 is larger than 9 over 26, right? Okay, so the first solution says x should be smaller than the two numbers. And of course, combined result is x should be smaller than the smaller number, which is 9 over 26, right? If you draw a diagram, it shows here. Of course, here is overlapped area, right? Okay, so how about the solution of the second problem? X should be larger than 9/26, and X should be larger than 2/3. And of course, here, this is the overlapped area, right? So X should be larger than the larger number, which is 2/3. Okay, so now we have these two solutions. X is either smaller than 9/26 or X is larger than 2/3. That means the final solution is X is either on this side or on this side, right? So this is our final solution here. Okay, have a look at this. Any questions? Okay, let's have a look at the next one. Question 5. Okay, again, this time we cannot multiply both sides using x minus 1 because we don't know the symbol, the sign in front of it, right? It could be a positive or negative number. So first of all, we rewrite the expression using common denominator. First of all, we put x minus 1 to the left-hand side of the inequality. This is, okay, if you consider this as a whole, if you move to the left-hand side, the sign in front of this expression changes from positive to negative, right? So negative x minus 1 larger than 0, right? And next step, we rewrite the expression here using the common denominator. Okay, and then expand and merge the numerator here. Okay, x minus 1 to the second, which is x squared minus 2x. There's a formula regarding this, right? Over x minus 1 greater than 0, right? And this is equivalent to minus 4x minus x squared plus 2x minus 1, right? Over x minus 1 above 0. And numerator is minus x squared minus 2x minus 1. So can you, this is actually a formula, right? We can factor this expression. Okay. If we put the negative sign in front, you can see that in the square, in the brackets, we have x squared plus 2x plus 1, right? So what is x squared plus 2x plus 1? Above 0. And this is equivalent to minus, of course, this is x plus 1 squared, right? Okay, now in order to make this problem simpler, we can multiply minus 1 to both sides. So minus 1 times minus x plus 1 to the second. Okay, if you multiply a minus 1 to both sides of an inequality, minus 1 is a negative number, right? If we multiply a negative number to both sides, remember to change the direction of the inequality symbol. Understand? We need to change the direction here. And 0 times minus 1, of course, is still 0, right? And this is equivalent to minus 1 times minus 1 here is 1. So x plus 1 squared over x minus 1 below 0, right? And you can see here now we have a ratio which is a negative number. So this is equivalent to the signs in front of the numerator and denominator should be different, right? So either the numerator is below 0 and at the same time the denominator is above 0, right? So negative number divided by a positive number gives us a negative ratio. Or we can also have a positive numerator and a negative denominator. So positive numerator divided by a negative denominator also gives us a negative number, right? And then we can solve these two sub-questions separately. So for the first sub-question, x plus 1 squared is smaller than 0. Does x exist? Does such x exist for something squared is below 0, right? We know that something squared must be equal or above 0, right? So there is no such x that can be satisfying this expression. So of course, x belongs to an empty set for the first sub-question. That means there is no solution for the first question, right? So how about the second one? Second one, x plus 1 to the second is above 0. We know that this expression must be above or equal to 0, right? If it is not 0, it must be above 0. So in order to ensure the expression is above 0, we must ensure that x is not minus 1, right? Because when x is minus 1, the expression x plus 1 squared is 0. If x is not minus 1, this expression here must be above 0, right? So this is the first condition, that x must be satisfying. Second, if we put minus 1 to the right, the solution is x must be smaller than 1, right? Okay, so these are the solutions of the two sub-questions. So this means x is either belongs to an empty set or x is smaller than 1, but x cannot be minus 1. So suppose this is 1, x must be smaller than 1, but x cannot be minus 1. So we need to remove this point. And so the final solution is x should be smaller than 1 and x cannot be minus 1, right? This is our final solution. And I strongly recommend that you check your result by putting minus 1 to the original expression. What will happen if x is minus 1? Let's check. So if x is minus 1, the left-hand side, okay, let's verify. If x is minus 1, what will happen there? If x is minus 1, the left-hand side is minus 4 times minus 1 over minus 2, which is minus 2, right? And right-hand side is minus 1, which is also minus 2. That means left-hand side is equal to the right-hand side, right? But the original inequality says the left-hand side should be strictly greater than the right-hand side. So x cannot be minus 1, right? This is the reason that x cannot be minus 1. Understand? Both of you. Okay, so next time, when you have a corner case, such as x being -1 in this question, you can verify your result. What will happen? Ask yourself the question, what will happen if x is -1, okay? Okay, next question. Okay, next question, the inequality sign is not strictly greater than or strictly less than, but there is an additional equality sign here, right? In these questions, the process would be a slightly different than the questions in than the previous 5 questions. So let's have a look at this. Okay, original inequality is equivalent to, of course, first step is to rewrite the expression like this and use a common denominator, right? Okay, so first 2 steps are actually the same. All right, and then this is equivalent to -4x plus 7. -1 times -3x, of course, gives us 3x and -1. Divided by the common denominator, which is -3x plus 1. And this is above or equal to 0, right? And let's try to simplify the numerator, which is minus x plus 6 over -3x plus 1 above or equal to 0. Okay, and now we need to detach this question into 3 different questions. Okay, so first of all, this expression here is above 0 or equal to 0. Is equivalent to, okay, first of all, this expression could be 0, right? Or this expression could also be greater than 0, right? So first of all, we detach this problem into an equation and an inequality. For the inequality here, the method to solve this is exactly the same with the ones we use in question 1 to 5, right? Okay, so first for the inequality, if the 2 ratios is 0, this is equivalent to the numerator must be 0, and at the same time the denominator cannot be 0, right? This is solution of the equation. Or if you have a ratio that is above 0, that means the signs in front of the 2 numbers are the same, right? So we can either have a positive numerator and at the same time a positive denominator, or a negative numerator and at the same time a negative denominator as well. Okay, so this is equivalent to the solution of the equation is x must be 6 and x cannot be 1/3, right? Or x is less than 6 and x is less than 1/3. Or can also have x is greater than 6 and x is greater than 1/6, right? Okay, so this is equivalent to x is 6 and x cannot be 1/3. If we combine these two, this is x is 6, right? Or x is smaller than 6 and x is smaller than 1/3. The final result of this is x should be smaller than the smaller number, which is 1/3. Or x is greater than the greater number, which is x can be greater than 6, right? And if we consider these 3, the final solution is either x is smaller than 1/3 or x is larger than or equal to 6. Understand? Any questions? No? Okay, let's see question 7. Okay, again, first of all, let's put everything in the left-hand side and rewrite this expression using common denominator. Okay, and this is equivalent to 6x plus 7 plus 40x minus 15, right? Over minus 8x plus 3, greater than or equal to 0. And this means after simplification, we have 46x minus 8 over minus 8x plus 3. Note that here we can divide both sides using a 2 to further simplify this. This means 23x minus 4 over minus 8x plus 3 should be larger than or equal to 0, right? Okay, so this means the ratio here is either equal to 0 or it can also be greater than 0, right? Okay. So the solution of the equation is 23x minus 4 must be 0. And at the same time, minus 8x plus 3 cannot be 0. Or if you have a ratio that is above 0, that means the signs in front of the numerator and denominator should be the same, right? So we can either have a positive numerator and a positive denominator, or you can have a negative denominator and at the same time a negative denominator, right? Okay, so this is equivalent to, let's solve these 3 sub questions one by one. First of all, x should be 4 over 23 and x cannot be 3 over 8, or x must be greater than 4 over 23 and x is less than 3 over 8, right? Or x is smaller than 4 over 23 and x must be larger than 3 over 8. Okay, so let's compare which number is larger. 4 over 23 is around 0.174, right? And 3 over 8, we know that this is 0.375. So of course, 3 over 8 is larger. So if we draw a number axis, this is 3 over 8 and 4 over 23 must be here, right? Okay, so now let's combine each of the solutions. First of all, x should be equal to 4 over 23. If x is 4 over 23, of course, x is not 3 over 8. So we don't need to write this again, right? Or x is larger than 4 over 23 and smaller than 3 over 8, according to the diagram here. So combined solution is x smaller than 3 over 8 and larger than 4 over 23. Or x smaller than 4 over 23 and larger than 3 over 8. According to the diagram here, there is no solution for such x, right? Okay, so final solution is x should be larger than or equal to 4/23, and x is smaller than 3/8. Okay, any questions? No? Okay, let's see next one. Question 8. Okay, again, original question is equivalent to minus 6x plus 7 over 4x minus 9. If we move -3 to the left-hand side, it becomes +3, right? And this is equivalent to, let's rewrite this expression using the common denominator. Okay, so its numerator is minus 3x plus 7 plus 12x minus 3 times minus 9 is 27. Okay, over common denominator is 4x minus 9 greater than or equal to 0. And this is equivalent to 6x minus 20 over 4x minus 9 greater than or equal to 0, right? And we can divide both sides using a 2 to further simplify this, because 2 is a positive number, so we don't change the direction of the inequality symbol here. This is equivalent to 3x minus 10 over 4x minus 9 greater than or equal to 0, right? Okay, now we have a ratio that is can be greater than or equal to 0. So this is equivalent to, first of all, the ratio here can be 0. Or it can also be greater than 0. Okay. And the solution of the equation is numerator must be 0. And at the same time, denominator cannot be 0, right? Or we have a ratio that is above 0. That means the signs in front of the numerator and denominator must be the same. So we can either have a positive numerator and at the same time a positive denominator, or we can have a negative denominator, a negative numerator, and at the same time a negative denominator as well, right? Okay, so let's try to solve each of these expressions. First of all, x must be 10 over 3 and x cannot be 9 over 4. Or x is larger than 10 over 3 and x is smaller than 9 over 4. Next is x must be smaller than 10 over 3 and x must be sorry, there's a typo here. This should be above 0, right? The signs of the two numbers must be different. And x must be greater than 9 over 4. Understand? Okay, now let's have a look at which number is larger. 10 over 3 or 9 over 4. 10 over 3 is 3.3 something, right? 9 over 4 is 2 point something, right? So which one is larger? Suppose this is 10 over 3, 9 over 4 must be here, right? 10 over 3 is larger. Okay, so by combining these three solutions, first of all, x can be 10 over 3, or x is larger than 10 over 3 and smaller than 9 over 4. There is no such x can satisfy both the two conditions here. Okay, third, x is smaller than 10 over 3, larger than 9 over 4 must be this interval, right? So x is smaller than 10 over 3, larger than 9 over 4. Okay, and final solution must be x is greater than 9 over 4 and smaller than or equal to 10 over 3, right? Any questions? Oh, okay, let's see question 9. Okay, original question is equivalent to put everything on the left-hand side. Okay, and x plus 2 becomes minus x plus 2, smaller than or equal to 0. Okay, and then rewrite the expression using the common denominator, which is x plus 2. So we have 8x minus x plus 2 squared over x plus 2, smaller than or equal to 0. Okay, and the numerator is 8x is 8x minus x squared plus 4x. Remember, there is a formula to expand this expression here, right? Over x plus 2 is less than or equal to 0. Okay, so after simplification, this is minus x squared plus 4x minus 4 over x plus 2 less than or equal to 0, right? And then if we times minus 1 to both sides, this becomes x squared minus 4x plus 4. Remember that minus 1 is negative, so we need to change the direction of the inequality symbol here. Okay, the reason why we do this is actually a formula. We can use a formula to factor this to x minus 2 squared divided by x plus 2 greater than or equal to 0, right? Understand? Can you follow me? Can you follow me? Okay, so this is equivalent to either the ratio is 0 or the ratio is above 0, right? And this is equivalent to, so the solution of the equation is the numerator is 0 and at the same time the denominator is not 0. Or, okay, again, if you have a ratio that is a positive number, that means the signs in front of the two numbers are the same. So you can either have a positive numerator and a positive denominator as well, or a negative numerator and at the same time a negative denominator, right? Okay, so the solution of the equation is x minus 2 squared is 0. That means x minus 2 is 0. So that means x is 0, x is 2, right? And at the same time, x cannot be -2. Or, okay, x plus 2 squared is above 0. So we know that anything squared is above 0 or equal to 0. As long as this number is not equal to 0, it should be above 0, right? So if we ensure that x is not 2, that means x minus 2 is not 0, right? If we ensure that x is not 2, we can ensure that x minus 2 squared is above 0. Understand? And x plus 2 is above 0. That means x must be above -2. Okay. And for the third sub-question, x minus 2 squared is -0. This cannot be happening, right? Because for any x minus 2 squared is a non-negative number. So there is no x that can satisfy this condition. So that means there is no solution for x. X must belong to an empty set. Okay, so this is equivalent to, first of all, x is 2 and x is not -2. Can be combined to x is 2. Or x is above -2 and x is not 2. This cannot be combined, so let's leave this here. And next is x belongs to an empty set. You can just leave it out, right? Because if there is no solution x, we do not need to consider this solution here. Okay, so the final solution is we can draw a number axis to help analyze. X can be 2, right? So x can be here. And this means x is larger than -2 and x cannot be 2. But combined with the solution of the equation, x can be 2, right? So the final solution is x is above -2. Okay. Again, you can always check the corner case. What will happen? So let's check, verify. What will happen? If x is 2, because x is 2 is a corner case, right? X is 2, when x is 2, left-hand side is, let's check the original inequality. When x is 2, the left-hand side is 16/4, which is 4, right? And right-hand side is x plus 2. X plus 2 is 2 plus 2 is also 4. That means left-hand side equals right-hand side. If left-hand side equals right-hand side, this can be happening because there is an equality sign here, right? So that means when x is 2, it satisfies this inequality here. So x is 2 must be one of the solution, right? So we can leave x is 2 in the final solution. We don't need to remove x being 2 in the solution. Do you understand? Any questions? No? Okay, let's see question 10. All right, question 10 is equivalent to, first of all, move everything to the left-hand side. So x minus 3 becomes minus x minus 3, right? And greater than or equal to 0. And we can then rewrite the expression using common denominator, which is x minus 3 squared over x minus 3 greater than or equal to 0. This means you have minus 12x minus x squared plus 6x minus 9 greater than or equal to 0, right? And this is equivalent to minus x squared minus 6x minus 9. Can you see that this is actually a formula, right? Minus x over 3 greater than or equal to 0. And this is equivalent to, let's multiply both sides using a minus 1. This gives us x squared plus 6x plus 9 over x minus 3. Remember that when you multiplying a negative number, you have to change the direction of the inequality sign here. Okay, so this is equivalent to x squared plus 6x plus 9. According to the formula, this is x plus 3 squared, right? Okay, so now this is equivalent to, first of all, this expression can be 0, right? Or the expression here can also be smaller than 0. And this is equivalent to, okay, for the equation, if the ratio is 0, that means the numerator must be 0 and the denominator cannot be 0. Or if you have a ratio that is smaller than 0, that means the signs in front of the numerator and denominator should be different. So this means you could either have a negative numerator and positive denominator, or you can have a positive numerator and a negative denominator, right? Okay, now let's solve this. X plus 3 squared is 0. That means x must be minus 3. And at the same time, x cannot be 3, right? Or, okay, again, something squared is less than 0. This means no matter what x is, this cannot happen because something squared cannot be smaller than 0. So the solution of the second problem is x belongs to an empty set, meaning there's no solution for this problem. Or, okay, for the third question, something squared is above 0. As long as it is not 0, it is above 0. So we only need to ensure that x is not minus 3, right? When x is not minus 3, x plus 3 is not 0. For a non-zero number, its squared must be above 0, right? Okay, x minus 3 smaller than 0 means x must be smaller than 3. All right, so let's combine these solutions. First of all, this should be an inequality sign here. First of all, x must be minus 3. Or x belongs to an empty set. Belongs to an empty set, you can just leave it out because there's no numbers in there. Or x smaller than 3 and x cannot be 3. Okay, first solution says x can be minus 3 and second says x cannot be minus 3. But remember that this is an OR operation. That means x can be minus 3, right? So the final solution is x is smaller than 3. As long as x is smaller than 3, the original inequality can be satisfied. Okay, have a look at this. Do you have any questions? No? All right, let's see question 11. Question 11 is of different type. So it asks you what is the possible range of k such that this system of inequality has no solutions for x. So for such question, usually we can solve the original inequalities first. So the original inequality is equivalent to, okay, so let's call this star, okay? So the system star is equivalent to, first of all, we can divide both sides using a 5 for the first inequality. This means x is larger than k plus 6 over 5. And for the second, we can divide both sides using a 2. Remember that 2 is positive, so they don't change the direction of the inequality symbol. So x is smaller than 8k plus 7 over 2, right? Okay, so now you can see that if we call this number is M1 and this number is M2, the solution of this system is actually larger than M1. This is M1 and smaller than M2, right? So if M1 is smaller than M2, there is solution, right? And if M1 is larger than or equal to M2, there is no solution. Why? Because you can draw a number axis. If M1 is larger than M2, this is M1, right? And this is M2. And system says X should be larger than M1 and should be smaller than M2, right? So in this circumstance, there is no overlapped area. So there is no solutions, right? As to whether we can include the inequality symbol, this is actually a corner case. You need to check very carefully, right? If M1 is M2, this means M1 is here and M2 is also here. The system says X is larger than M1. Larger than M1 is here and smaller than M2 is here, right? In this circumstance, there is also no solutions, right? So we can include in the equality sign here. The conclusion is if M1 is greater than or equal to M2, there is no solution. That means we can let M1 is k plus 6 over 5. And M2 is 8k plus 7 over 2, right? So we can see that if this happens, no solutions for x. Okay, this means we can just solve this inequality here, right? Let's call this 2 stars. Star, star, okay? And so 2 stars is equivalent to, okay, you can time a 10. We can multiply a 10 to both sides, right? 10 is positive, so we don't change the direction of the inequality symbol. If you multiply 10 to both sides, this gives us 2 times k plus 6 greater than or equal to 5 times 8k plus 7. This means 2k plus 12 greater than or equal to 40k plus 35, right? And this is equivalent to 38k. Smaller than or equal to minus 23, and this is equivalent to k smaller than or equal to minus 23 or divided by 38, right? So the final solution is if k is smaller than or equal to minus 23 over 38, no solutions for x. Okay, this is a whole reasoning process for this question. Have a look at this. Do you have any questions to ask? Any questions? Okay, so here, this is actually the reasoning process. You don't have to include this in your answer sheet, okay? This is a thinking process. Let's call this reasoning process then. No questions? All right, let's see question 12. Actually, these methods are pretty similar, right? First of all, let's try to solve the system first. Okay, let's call this system star. So star is equivalent to, first of all, x is smaller than 9m minus 4 over minus 8. Remember here, we divide both sides using minus 8. Minus 8 is negative, so we need to change the direction of the inequality symbol, right? And next, we can have x is greater than 7m plus 1 over 9, right? Okay, again, let's call this K1, and this is K2, right? So under what circumstance there's no solution for x? So let's say if K1 is here and K2 is here, this means x is smaller than or equal to K1 and greater than or equal to K2. So in this case, there is no solution, right? In this case, this means K1 is smaller than K2. If K1 is smaller than K2, there is no solution, right? Okay, the question, one of the question is, can K1 be equal to K2? So what could happen if K1 equals K2? If K1 equals K2, so K1 and K2 is here, right? So under this circumstance, the original system says x is smaller than K1 and smaller than or equal to K1 or greater than or equal to K2. This means the solution is x equals K1 or K2, right? So in this circumstance, there is solution. So you can't include K1 equals K2 in your reasoning, right? In other words, when K1 is K2, when K1 equals K2, there is a solution for x. So we don't include this situation, right? So the conclusion is if K1 smaller than K2, no solutions for x, right? And let's call this 2 stars. And 2 stars, double star, is equivalent to K1 is 9m minus 4 over minus 8. K2 is 7m plus 1 over 9, right? All we need to do is to solve this inequality. We can multiply a minus, sorry, not minus, we can multiply both sides using the least common multiple of 8 and 9, which is 72, right? Okay, so this means left-hand side becomes minus 9 times 9m minus 4. Okay, 72 is positive, so we don't change the direction of the inequality symbol here. And 8 times 7m plus 1 here. Okay. And this is equivalent to minus 81m plus 36, smaller than 56m plus 8, right? And this is equivalent to 137m greater than 28, right? Which is equivalent to m is greater than 28 over 137, right? So the final solution is if m is greater than 28 over 137, there is no solution for x. Understand? Any questions? Okay, have a look at this. Do you have any questions? No? Okay, let's see the last one. Last question. It asks you under what circumstance there is no solution for x in this system. So first of all, we can try to solve this for x. The original system star is equivalent to x. Okay, for the first one, we can divide both sides using -2. -2 is negative, so we need to change the direction of the inequality symbol, right? Minus 4n minus 7 over -2, right? And next, x is smaller than 5n plus 8 over 3, right? Okay, and of course we can cancel a -1 to the number here. So this becomes 4n plus 7 over 2. We can cancel 1 here, right? Okay, so let's call this K1 and this is K2. So under what circumstance there is no solution for x? We can consider the relative positions of K1 and K2, right? So if K1 is here and K2 is here, it says x must be greater than or equal to K1 and x must be smaller than K2. So in this case, that means if K1 greater than K2, no solution, right? Because there is no overlapped area. Okay, the question is that can K1 equals K2? So let's consider this. If K1 is K2, if K1 equals K2, they are actually on the same point, right? First of all, x is greater than or equal to K1. So x is here, must be to the right-hand side of K1 or K2, right? Second of all, x must be smaller than K2. Remember that K2 is also here, so must be smaller than K2 is here, right? So under this circumstance, are there any overlapped areas? Of course, there is not, right? Because x is greater than or equal to K1 and x is smaller than K2, which is also K1, there is no overlapped area, right? So in this case, there is also no solution. That means if K1 equals K2, no solutions as well. Okay, so only in these two circumstances, there's no solutions. Otherwise, if K1 is here and K2 is here, X is greater than or equal to K1 and smaller than K2. This is the overlapped area. There is no solution. There is a solution in this situation, right? Okay, so this is our reasoning process. You don't have to include it in your worksheet, okay? You can draw this on your scratch paper. And on your worksheet, you can write like if K1 greater than or equals K2, no solutions for X, right? And we know that K1 greater than or equal to K2 is equivalent to, okay, K1 is 4n plus 7 over 2. And K2 is minus 5n plus 8 over 3. Okay, we can just solve this inequality. Can multiply both sides using the least common multiple of 3 and 2, which is 6. So this gives us 3 times 4n plus 7. Okay, 6 is positive, so we don't change the direction of the inequality symbol here. Times 2 times minus 5n plus 8, right? And this is equivalent to 12n plus 21, greater than or equal to minus 10n plus 16. Am I correct? Okay, let's simplify this. That means 22n greater than or equal to minus 5, right? And this is equivalent to n should be greater than or equal to minus 5 over 22, right? So this means if n is greater than or equal to minus 5 over 22, there is no solution for X. Okay, and this is our final solution of the last question. Okay, have a look at this. Do you have any questions? No? Okay, so if you don't have any questions, this is end of for today's class. So remember to download the new assignment probably tomorrow, okay? And I'll upload teacher's notes of this assignment onto our Google Classroom for you to refer to. And please also note that you need to correct these assignments if you have not done them correctly, okay? Have a nice weekend and I'll see you next Saturday, okay?